How important are semiconductors to the business of AI? And is AI the only technology? Are semiconductors only part of electronic components?
Semiconductors are working to power both of our devices, store data, and keep us connected for our conversation. And these chips are embedded in everything from satellites to medical devices to electric vehicles.
Hello and welcome to Technocracy. I am Heena Goswami, editorial consultant with IGPP, Institute for Governance, Policies and Politics, New Delhi. Those amongst us who remember the basic science that we studied in high school must remember that materials that conduct electricity are known as conductors, and materials that do not conduct electricity are known as insulators. So you might be wondering, what are these semiconductors and why are they heightening geopolitical tensions? So today, in our two-part series on semiconductors and chip war, let's discuss what semiconductors are and why are they so integral to the modern technology. Semiconductors are materials that under certain conditions can conduct electricity and under others they can resist it. They can control the flow of electricity, which makes them perfect for building electronic components like transistors. In most modern technologies, semiconductors act like tiny electric switches, turning off and on repeatedly to enable the flow of electricity. Semiconductors are widely used across many industries and gadgets, including your phone, laptop, smartwatch, as well as in industrial manufacturing, where large amount of power has to be conducted through a small area. As semiconductors are the foundation of modern electronics, the specialized semiconductors that are used in AI chips are indispensable for AI revolution. Using semiconductors, we build transistors, and millions and billions of transistors are combined to make AI chips. AI chips use these transistors to do fast calculations and run AI tasks like image recognition, speech processing, or language understanding. Think of an AI chip like a huge city full of workers solving math problems. The semiconductors is the land the city is built on, and it's special because it can support roads, power, and buildings. The transistors are like the tiny workers in the city. Each one can turn on or off like flipping a light switch. The more workers or transistors you have, the more problems the city can solve at once. Because AI needs to solve a ton of problems really fast, it needs a city or a chip with millions or billions of these workers. And none of this would be possible without the semiconductor land underneath it all, making everything work. So the main requirement for AI system is great computing power, which is where the semiconductor companies come in. They design and manufacture the specialized hardware needed to meet AI algorithms' huge application requirement. Leading edge specialized AI chips are essential for cost effectively implementing AI at scale. And these include graphing processing units, GPUs, field programmable, gate arrays, FPGAs, and application specific integrated circuits, ASICs, that are specialized for AI. AI chips are optimized for massive parallel processing, doing many calculations at once, which is critical for AI workload like neural networks. General purpose chips like central processing units, CPUs, can also be used for simpler AI tasks. But CPUs are becoming less and less useful as AI advances. Semiconductors are primarily made from elements like silicon and germanium, which are then often mixed with impurities in a process called doping to control their electrical conductivity. Semiconductors are manufactured in foundries, which are highly specialized companies that focus exclusively on semiconductor manufacturing, leaving design and distribution to others. The relationship between semiconductors and AI is an interdependent one. AI's rapid growth fuels the demand for semiconductors that are smaller, faster, more energy efficient, while semiconductor advancement enable breakthroughs in AI capabilities. Emerging technologies like silicon photonics, which combine optical and electronic components on a single chip, are also showing promise in addressing the growing computational demands of AI. Moreover, semiconductors are critical to expanding AI applications at the edge, where devices like autonomous vehicles and wearable technology require high performance chips that can process data locally with minimal power consumption. This push for edge AI solution highlights how advancement in semiconductor design, such as system on chip architectures, are shaping the future of AI by making it more accessible, scalable, and omnipresent. The world's unchallenged leader in the production of raw semiconductors is Taiwan, where Taiwan Semiconductor Manufacturing Corporation produces around half of the semiconductors produced worldwide. In contrast to corporations like Samsung and Intel, who make semiconductors for their own product, Taiwan Semiconductor Manufacturing Corporation produces semiconductor for a wide range of other businesses, including Apple, AMD, Nvidia, and others. This business model is referred to as the foundry model. To dig a little deeper into what semiconductors are and why control over them is leading to geopolitical tensions, today we are joined by Miss Lily Bermudez. Miss Lily serves as a research data technician for Duke University's Deep Tech program supporting quantum computing initiatives. Prior to her current role, Miss Lily was an independent researcher with the Center for Humane Technology investigating encryption within the AI and quantum computing nexus. So, welcome to Technocracy, and I'm going to dive into questions right away. How important are semiconductors to the business of AI? And is AI the only technology? Are semiconductors only part of electronic components?
So, semiconductors are absolutely foundational to AI. They are the physical infrastructure that makes modern AI possible. So, at the heart of AI operations are GPUs or graphics processing units, which are specialized chips originally designed for graphics rendering, but they're now essential for training and deploying AI models. GPUs enable parallel processing, which is the performance of thousands of simultaneous computations, which is crucial for deep learning, pattern recognition, and large scale data analysis that power today's AI systems. Um, but to the second point of that question, AI is far from the only technology dependent on semiconductors. As you and I have this chat right now, semiconductors are working to power both of our devices, store data, and keep us connected for our conversation. And these chips are embedded in everything from satellites to medical devices to electric vehicles. And semiconductors have actually sort of reshaped the digital age and are now integrated into virtually every aspect of modern life. And it's this ubiquity that is precisely what makes semiconductor supply chains so geopolitically significant.
So, who are the countries that are leading the innovation relating to semiconductors, and why? How does Taiwan's name pop along with US and China? How is this small nation at the heart of this rivalry?
Great question. So, the semiconductor ecosystem currently is remarkably fragmented across the globe, with different countries and regions specializing in distinct phases of chip development. So there are four main areas of semiconductor research and development. You have design and development, you have fabrication, you have testing and assembly, and then you have distribution. Now, the United States leads in chip design, as evidenced by our fabless companies such as NVIDIA, AMD, and Apple, which are all companies that design cutting edge chips, but ultimately end up outsourcing much of their manufacturing. So that's where you have other countries such as South Korea, Japan, the Netherlands, and China, who are also big players in the semiconductor industry. But China in particular is investing heavily to build domestic capabilities across the entire semiconductor supply chain. Now, Taiwan's extraordinary position stems from one company, and that's Taiwan Semiconductor Manufacturing Company, or TSMC. And TSMC is currently the world's largest and most advanced chip manufacturer, producing over half of the world's most sophisticated semiconductors. Um, Currently, the company has mastered the fabrication process, which is what entices fabless companies like Apple and NVIDIA to strike these international deals with TSMC. So, as such, these international deals are creating a lot of geopolitical vulnerability for both the West and nations like Taiwan. Moreover, given Taiwan's proximity to China, if conflict were to disrupt TSMC's operations, it would trigger a huge technological crisis that can affect everything from our consumer electronics to our defense systems. So, this geopolitical arrangement is exactly why semiconductors have positioned Taiwan as a powerhouse in the industry. Now, Taiwan's extraordinary position stems from one company, and that's Taiwan Semiconductor Manufacturing Company, or TSMC. And TSMC is the world's largest and most advanced chip manufacturer, producing over half of the world's most sophisticated semiconductors. Taiwan, in particular, often shares a huge slice of the market when it comes to raw and manufactured materials such as silicon wafers, photomasks, and photoresists, along with certain chemicals, which are all necessary inputs across the semiconductor manufacturing process. And that, along with Taiwan's proximity to China, is what positions Taiwan to be a powerhouse in the semiconductor industry.
But we see that the US has also introduced export control measures to choke off China's access to leading edge semiconductors. Why just single out China? Do you think that this rivalry is not just limited to technological innovation, but also has an ideological angle to it?
While the immediate concerns center on technological and military advantage for the United States, there is a deeper contest over economic sovereignty, national security, and ultimately just competing visions of technological governance. So, from the US perspective, semiconductor dominance is about maintaining economic competitiveness and preserving national security. And you see this evidenced in legislation such as the CHIPS and Science Act, which passed in 2022 with bipartisan support, provided $52 billion to grow domestic research and manufacturing, all with a through line of national security and economic concerns. However, the goal of the US is also about independence or technological sovereignty. So the US ultimately wants to put more control into the hands of Americans throughout the entire semiconductor pipeline. from initial chip design all the way to final product integration, which all has the aim of reducing dependence on international supply chains that could potentially be disrupted by geopolitical tensions or conflict. And in regards to China, I do think China views things a bit differently. I think China views semiconductors as essential to technological sovereignty and likely views export restrictions as a form of exclusion. In response, we are seeing Chinese investment in their domestic semiconductor capacity. And ultimately, as previously mentioned, I do think the rivalry does reflect two competing visions regarding semiconductors, with both the US and China competing in a technological race and an ideological struggle over the future of international order.
But do you think that this export control policy in specific is having the reverse impact, and instead of limiting um, China's technological advancement, it is spinning off innovations?
Great question. I think in certain respects, yes. Restrictions do appear to be accelerating specific aspects of Chinese innovation and potentially creating unintended consequences. Um, as previously stated, Chinese semiconductor investment has intensified dramatically in response to export controls. And we see this through the direction of funding towards their domestic chip production, workforce development, and research infrastructure. This pressure from export controls has galvanized resources, political will, and national focus in ways that might not have occurred absent external restrictions. However, there are still significant limitations to what forced innovation can accomplish in the near term. So, semiconductor fabrication isn't something that can be rapidly replicated through investment alone. It still does require decades of knowledge, specialized supply chain integration, and access to equipment that often cannot be easily substituted or even reverse engineered. So I do think the greater concern regarding these restrictions is that it might incentivize China to build a parallel technological ecosystem based on different standards, which could introduce inefficiencies, increase costs globally, and potentially create instability when it comes to our technologies.
In the foreseeable future, do you think there might be some alternative to semiconductors? And if not, how do we ensure that the technology based on semiconductor does not lead the world to be divided into geopolitical blocks, especially when they are also ideologically very different?
In the foreseeable future, like within the next 10 to 15 years at minimum,
Yeah.
I think silicon-based semiconductors will remain dominant, while there is research into alternatives like quantum computing. These technologies are still either highly specialized in their early stage or face fundamental scaling challenges that do prevent alternatives from replacing conventional semiconductors broadly. So ultimately, I think any alternative would need dramatic advantages to justify the transition costs and rebuild the entire supply chain from the bottom up. The way forward, I think, is to continue investing into specialization in the semiconductor industry. That can take the form of a variety of outreach programs, educational initiatives, um, all at the expense of funding mechanisms that would need to be instituted in a variety of scales.
Can you elaborate a little more on what quantum technology is and how can it change the landscape of tech rivalry or reinforce it even further?
Classical computers, which we interact with every day, that they use binary bits, and quantum computers use qubits, which exist in multiple states simultaneously and ultimately enables exponentially faster problem solving for specific tasks. However, the biggest challenge that quantum technologies face is that qubits are extraordinarily sensitive to errors and require breakthroughs across a variety of disciplines to manipulate them. And this complexity is what makes quantum computing also geopolitically significant, since the nations that master it will gain an advantage in compute power. And to tie this back into semiconductors, it is possible that quantum technology will both intensify existing rivalries and create new competitive dynamics following similar patterns that we've seen with the semiconductor industry. However, it is still very difficult to base that comment on anything tangible thus far, since quantum technologies are facing immense scalability challenges and a bunch of other obstacles, which ultimately leaves us to only make assumptions for the future based on what it promises.
Does quantum technology use as many semiconductors as the AI does?
It can. It can. So, what many institutions and private companies are researching is trying to manipulate these qubits onto small commercialized chips. And that takes an immense amount of research, funding, etc., to actually be able to manipulate these chips to put them in consumer devices. So it is possible, but I don't think we're near that sort of scale yet.
Thank you so much for joining Technocracy and sparing time for this conversation.
If you enjoyed watching this episode of Technocracy, please like, share, and subscribe to our channel. For more AI related conversation, you can also watch IGPP Expert Talks AI Special Series.